Hey Opties! Today we're going to be factoring when a is greater than 1. Remember that we've been factoring trinomials when a is equal to 1. We've also done some GCF factoring and some difference of squares factoring. So let's go ahead and remind ourselves of how it works when a does equal 1. So the first step is we want to look for two factors of c that add to b. And then we want to write two sets of parentheses with an x at the beginning of each, and then write the factors from step 1 into the blanks. And then we're done factoring. It's really as simple as that. We do have a point to ponder, and that is what's going to relate us to when a is greater than 1. Since a equals 1, for these examples, you only need to look for factors of c that add to b, since a times c is equal to the same as c. So a times c equals c since a equals 1. And what we're going to do in the second example, when a is greater than 1, is we'll find factors of a times c. And if you would like to think about a equals 1 examples as factors of a times c, you certainly can, because a is 1 and it really is the same thing. So let's take a look at an example. We have y equals x squared plus 4x minus 12. And we want to find factors of 1 times negative 12. And that's how we got this negative 12 here. That's our a times our c. And we've listed all the factors. And there's more factors since it's a negative. You've got to consider all the negatives. So not just 1 and 12, but 1 and negative 12, and then negative 1 and 12, and so on. The two we found that also add to b are negative 2 and 6, and our b value was 4 because it's the coefficient of our x term. So we factor it by putting both of these in with our x in our parentheses, so we would have set it up like this before we put those in there, and the order can be swapped because of commutative property of multiplication. And then we can check our answer by distributing. So if we distribute, we'll get this, and then if we combine these two like terms, we'll get this. Now here is giving us a reason of what we're going to do in just a moment. Notice that these two terms that we have in the middle that equal our bx term come from our two numbers that were the factors that added together to b but multiplied to a times c. And we just put an x with them and they equal that b term. So we're going to use that knowledge in our a is greater than 1 example. When a is greater than 1, we're going to for sure look at factors of a times c that add to b. And what we'll do is we'll use an organization tool with our Punnett square you see here, which is just a 2x2 square. And that will help us organize our ideas, and then we can find the GCF of all of the columns and all the rows, and that will tell us our factors of our original trinomial. So let's take a look at an example. We have 3x squared minus 5x minus 12. So we've listed the factors of a times c. Again, this negative 36 comes from 3 times negative 12, since this is a and this is c. And that's how we get our negative 36. So we listed all of their factors, including all the positive and negatives, that's combinations. And the one that we found that adds to b, which is our negative 5 here, is 4 and negative 9. So if you remember from up above, when a equals 1, those two terms that we found, those two factors, so the 6 and the negative 2 here, but what are our 4 and our negative 9 here, they can replace the b term. That's the whole point in finding them, because not only do they work with the addition to replace that b term, but they work with the multiplication. This is the strategy, the factors of a times c that add to b, that allow us to find those numbers that work for both of those, for the adding and the multiplication. So this 4 has become a 4x, and this negative 9 has become a negative 9x. So let's take a look at what we do next. We've put our top left of our Punnett square as our ax squared term. And our bottom right is our c term. And then these two are our factors. And then we put an x with them. So this is always the setup. And now we want to find the GCF of each. So the GCF of 3x squared and 4x goes here, and that's just an x. So you're looking for all the number pieces and the variable pieces that would be that GCF. The negative 9x and the negative 12 is going to be that negative 3. So this 3x would be the GCF of 3x squared and negative 9x, and this 4 is the GCF of 4x and negative 12. So then our final factored form is just putting these together as our binomials, and that's how we get this factored form here. Let's take a look at some practice. So number 1 says factor the trinomial. I'm going to show you the Punnett square, and I'm also going to show you what it would look like if you didn't use that organization tool and you just used what we call grouping, factoring by grouping, which is really what we're doing with the Punnett square. It's just a little bit better of an organization. But in case you like just writing it out, I'm going to show you this method. So we're going to look for factors of a times c. And then once we find those, before we count all of them, if we find what adds to b, then we can be done. So a times c is going to be 6 times negative 2, which is negative 12. So we're looking for factors of negative 12 that add to b, which is 1. Okay, so we might be able to figure this out quickly. So you want to find numbers that are close together that are factors of 12. One thing you could do without considering all the positive and negatives by just writing them out is you could just do all of the positive factors of 12. So 1 and 12, 2 and 6, 3 and 4, and then you can think about where the negative would go to help you find whatever adds to the b. So we want to be a 1 positive. So 3 and 4 are one place away from each other. So if we make the 3 negative, then that will give us what we want. So negative 3 and 4, since negative 3 plus 4 is 1, and we also know that negative 3 times 4 is negative 12. Otherwise, we wouldn't have written it here for factors. So we have our two pieces of our Punnett square. So let's draw our Punnett square. Remember, the top left is our ax squared term, so that's our 6x squared. Our bottom right is our c term, so our negative 2. And then we're just writing out our trinomial here, but we're breaking it down into 4 terms. And our two other terms are using what we just found. So we've got our negative 3, but x, because we're trying to replace this b term. And then we've got our positive 4x. So if we added these together to get our trinomial, our negative 3x plus the 4x would give us x, which goes to our existing b term, and that's what we want to see there. Now let's find the GCF of each piece, because remember, the first thing we want to try to do if we're factoring is find the GCF. And we actually didn't try to do that here, but it was pretty obvious there was not any GCF because one of your coefficients is a 1. So let's go ahead and do our GCF. I'm going to start with this first row. So 6x squared and negative 3x. So let's think about our number pieces. They both have a positive 3 and they both have an x. So we're taking out the biggest things they share. I kind of think about it as the number pieces first and then the variables. Okay, so let's look at 4x and negative 2. They both share a positive 2. Okay, and there's no x term to be shared because our negative 2 doesn't have an x. Let's look at this first column. So 6 and 4 both share a 2 and they both have an x. And then we have a negative 1 shared here. Okay, so this is our factored form. If we just write these as two binomials, so 2x minus 1 and 3x plus 2. Now, if we want to check to see if we're right, we can distribute, which I suggest doing if you're unsure. So let's start with our 2x plus our 3x, which is going to be 6x squared, which so far we're correct because that's our ax squared term. And now let's do our 2x times a 2, so that's our 4x. And hey, we got back to one of our terms that we put in our Punnett square, which is a good sign. Now we've got our -1 times a 3x, which is -3x. And that's another good sign because we have that term here too. And hopefully we'll get -2, and we do with our -1 times a 2. So we can add those like terms, the 4x and the -3x, and that's our plus x minus 1. And now we're to our original quadratic. And that's good because that means that we've done it correctly. Okay, so let me show you if we didn't do the Punnett square, here's what we would do. We would simply just write our ax squared, and we're still going to replace our b term, or our bx term, with our -3x and our positive 4x, because remember, that's equivalent. And then we have our -2. So now we're going to factor by grouping. We're going to group our first two terms and our second two terms, and it's really the same thing we've done here, but it just depends on what you like better. So let's find the GCF of these. That's going to be a 3x. Hey, didn't we have a 3x earlier? Yeah, we did, so that's good. And now we have to figure out what's left over. So this part makes it maybe a little harder if you have to figure out what's left over, and here you don't. You just have to do the GCF over and over. Okay, so 6x squared divided by 3x is 2x, and -3x divided by 3x is -1. Now notice this is one of our factors, and we see that here. So that's a good sign. We're doing it two different ways, and we're getting to the same thing. So now we are going to factor out the GCF of 4x and -2, which is going to be a +2. So +2, and 4x divided by 2 is 2x, and -2 divided by 2 is -1. Now, notice that what's in our parentheses are the same. If that happens, that's a really good sign. It means you're probably right. I mean, if they're not the same, you're definitely wrong. Think about if you were asked to factor 2x plus 4x. The x's are the same, so you can take them out by factoring them out. That is the GCF of those two terms. Then you're left with 2 plus 4, okay? And that's exactly what we're going to do here. We're going to factor out our common factor, our GCF, of the whole entire two terms, and that is 2x minus 1. And then what's left over are the pieces on the outside, the 3x plus the 2. 2x minus 1 is a factor. It's the GCF of this first term and the GCF of this second term, so the GCF of the whole entire thing. And then we're left with multiplying by 3x plus 2, just like we were left with the outside pieces 2 and 4. And that is our factored form, and see, it matches what we did over here. So either way, whatever works for you, go for it. I'm going to stick with the Punnett square because I like the way it organizes things, and I think it's a little easier on the eyes. But if you like this way, it's called just factoring by grouping without the extra organization piece, go for it. Let's quickly go through the next three. Number 2, 6x squared minus 4x minus 16. So you might notice there is a GCF, and the GCF is 2. So let's factor that out. So GCF, just right off the bat, we get 3x squared minus 2x minus 8. So now we get to factor our trinomial in the inside of these parentheses. So we're going to do factors of a times c, and that's going to be 3 times -8, which is going to be our -24. And then we're going to find what adds to b. So if you want to kind of make a multiplication then a plus without writing out the words factors and adds to, then that's okay. That's what I'm doing here. So b is -2. So, okay, so -2 is pretty small, so we want to find the factors of -24 that are pretty close together. Again, if you want to list them all, positive, and then you can go through and figure out what needs to be negative to work. So 1 and 24, 2 and 12, 3 and 8, and 6 and 4. Okay, 6 and 4 are two apart, and we want it to be negative, so we want the bigger one to be negative, so we want it to be -6 and 4. Okay, so we've got -6 plus 4, and that is -2, and -6 times 4 is indeed -24. So we know it works, so let's use it. We're gonna make our Punnett square. We cannot forget about this 2 in the end, but we don't need to include it in our Punnett square, because on the Punnett square, we're only factoring that inside piece, and we've already taken care of the GCF of 2. Top left is our ax squared, so 3x squared. Bottom right is our c term, so -8. Now we're going to replace our bx term, so our -2x, with the -6x and the +4x. So let's do the GCF of the first row. That's going to be a 3 for our number piece and an x for our variable piece. GCF of the second row is going to be 4, so a positive 4. GCF of our first column, in terms of numbers, it's a regular old 1, and then we do have an x here. And then -6 and -8, or -6x and -8, we've got a negative something that's going to be a -2. Okay, here are our factors. So the factored form is, don't forget our 2 out front, so that came from here. We've got to keep that here. And now our inside piece has become 3x plus 4 times x minus 2. And you, again, can check that by distributing. Number 3. So we see that it's a cubic. We haven't learned how to factor cubics, so it's possible that this is a GCF. And if you look till the end, you see there's an x in each piece. So we are going to have our GCF to be partly an x. And you may also notice that all of these numbers are multiples of 3. So we're going to take out a 3 as well. So y equals 3x times the quantity of 36 divided by 3 is 12. And then our x cubed divided by x is x squared. 33x squared divided by 3x is going to be 11x. Then we've got our 6x divided by 3x, which is just positive 2. Okay, so now we're going to factor the product or factors of a times c. So factors of 12 times 2, which is 24. Hey, we got more factors of 24. And we want to add to 11. Okay. So factors of 24 that add to 11. That's they're all positive this time, so that's no negativeness. So let's think 1 and 24, 2 and 12, 3 and 8, and 6 and 4, or 4 and 6 if I was keeping with the pattern, but it's okay. So which of these add to 11? 8, 9, 10, 11, that's going to be 3 and 8. So let's make our Punnett square. Let's not forget about the 3x in the end though. Okay, so 12x squared in the top left, 2 in the bottom right, and then we've got 3x and 8x. So let's find the GCF. That's going to be 3x, 2, or positive 2. Let's put the plus there. 12 and 8 would be 4. We've got an x there as well. And 3 and 2 would just be a 1. And there's no x either. Quick things to check. You can probably just do your distribution by looking at here. So like 3x times 4x, is that going to give you this term right here? Yeah, that's going to give you the 12x squared. Does 4x times 2 give you 8x? Yes, it does. And that's a good check, because this is really just like you're undoing multiplication. That's what factoring is. You're undoing your distribution, right? That's the reason you distribute, to check. So it's really like a multiplication table. 2 times 1, is that 2? Yes. And then 3x times 1, is that 3x? Yes. So you're good. You factored completely. That's another way to check without actually doing your distribution. I mean, it is distribution what you just did, really, but you don't have to write it like linear like this. Okay, you're done with that one. And 4. Factors of a times c, which are going to be 3 times 4, which is factors of 12, that add to b, which is -8. Okay, so factors of 12, 1 and 12, 2 and 6, 3 and 4. Add to -8. So since it's negative, then both of these numbers have to be negative for the two factors, because you can do a -1 times -12, and that's still positive 12, right? So you've got to think about positive and negativeness based on what your b is. So 6, 7, 8, that gives you to 8. But if they're both negative, then that gets you to -8. So it's going to be -2 and -6. These are our special numbers to replace our b. We're making our Punnett square. Okay, 3x squared. Bottom right is our c, which is 4. And then we've got -2x and -6x. Okay. GCF of the row, it's going to be just an x, because 3 and 2, They don't have any common factors. We've got -6 and 4 for this next row. That's going to be a +2. One way you could figure out what this is without doing the GCF is what can you multiply by x to get you to 3x squared. It's got to be 3x, but you can also do the GCF. Just trying to think of different ways for you to also think about it. And same thing here, like what can you multiply by x to get you to -2x? It's got to be a -2. And -2 times 2 is also a 4. So that's some other ways to check. So our factored form is 3x minus 2 times x plus 2, and we are done. All right, I know that was lengthy. Hopefully you learned what skill works best for you, whether it's just the Punnett square, whether it's checking with distribution after you've written your factor out, or you're just checking to make sure that your multiplication runs together like this. Whatever works for you. This is factoring when a is greater than 1. See y'all next time.